Good morning, students. This is lecture 4. In lecture 1, we had discussed about parts of coordination compound. We get introduction of coordination compound in lecture 1. In lecture 2, we had discussed nomenclature of coordination compound. In lecture 3, isomerism in coordination compound. And here in lecture 4, bonding in coordination compound. Very, very important part. It is for examination point of view, right? So bonding in coordination compound we are going to discuss here. In coordination compound, remember it, in coordination compound there is three type of bonding is responsible to define. Three important theories are responsible. Two more are there also, but these theory are not, other two are not included in your syllabus. So these three important theories, those are included in your syllabus. For bonding in coordination compound. The first is Werner's valency theory. The other one is valence bond theory. And the last one is crystal field theory. Right. The first theory is Werner's valence theory. According to Werner valence theory, there are four important postulates for Werner's valence theory. One is, in coordination compound, metals show central metal ion, central metal atom, right? So in coordination compound, metals show two type of linkage. One is primary linkage and other one is secondary linkage. In primary linkage, the primary valence are normally ionizable and are satisfied by negative ions. Primary valence are normally ionizable and satisfied by negative ion. Nowadays, the primary valence is considered as oxidation state of central metal atom, central metal ion. That would be considered as primary valence. That would be satisfied by negative ions according to Werner. The secondary valence are non-ionizable and these are satisfied by neutral molecule or negative ion. Secondary valence is equal to the coordination number and fixed for a metal. So it is very clear, secondary valence is equal to coordination number. Right, so coordination number is secondary valence and oxidation state of central metal ion primary valence according to Werner's valence theory. The ion groups bound by the secondary linkage to metal have characteristic spatial arrangement corresponding to different coordination number that we termed as coordination polyhedra. Spatial arrangement, that is coordination polyhedra. So Werner postulated four different postulates to define their valence theory. Right. So in case of valence theory, let me discuss about what will happen. For example, Cr NH3 whole thrice, right? Yeah, NH3 whole 6 and Cl3. So this chromium is +3 oxidation state as we know here. So it is primary valence. ये क्या हो जाएगा? Primary valence हो जाएगा according to Werner. And 6 NH3 is there. So that is NH3, 6 NH3 would be considered as secondary valence, जो कि coordination number है. So coordination number will be secondary valence. Coordination number will be secondary valence. Generally, according to Werner, primary valence is always ionizable. So Cl3 is always ionizable as we know. And the secondary valence is non-ionizable. NH3 is non-ionizable as we know. But nowadays it is not 100% applicable. इन्होंने जो बताया था वो अपने लेवल पे था, but nowadays it is not 100% applicable, right? For example, we can see CO. Here one compound is also mentioned. You can see COCl3.6NH3. So what he found when he treated this compound with AgNO3, 3 molecules of AgClPpt, 3 mole of AgClPpt. Then this compound, what he found, 2 molecule. This compound, what he found, 1 molecule. This compound, what he found, 0 molecule. So by this observation, he mentioned these all postulate. Right? He mentioned that 2 type of linkage, primary, secondary. The second primary one ionizable, so we can find so in first case 3 chloride ion we could get. So अगर अब हम बात करें इनके स्ट्रक्चर की, अगर मैं इन्हें चारों कंपाउंड का स्ट्रक्चर बताऊं जिसके हिसाब से उन्हें अरेंजमेंट मिले हैं, तो पहले कंपाउंड का स्ट्रक्चर क्या होगा देखिएगा, CO NH3 whole 6 and Cl3. So when we put into water, what we would get, CO NH3 whole 6 3 plus and 3 Cl minus. And when this Cl minus is there treated with AgNO3, we know, so we would get AgClPpt 3 mole and NO3 minus remain as it is. In second case, if one NH3 is there, one less NH3 is there, CONH3 whole 5, and it is Cl inside, because coordination number will never change. That's why he said that secondary valence is managed or satisfied by neutral or anion also, right? And outside will be Cl2. So in this case, जब इसका हम न्यूट्रलाइजेशन करेंगे, what we would get, NH3 whole 5 NH3 whole 5 Cl, and here is that 2 plus charge and plus 2 Cl minus, and when AgNO3 again will treated with it, what we would get, 2 mole of AgCl and NO3 minus also. Now in next case what would happen, CO NH3 whole 4, so Cl2 were there, Cl2 are there, so in that case 1 Cl is outside only. So on when this compound added in water, what we would get, NH3 whole 4 Cl2, this is complex ion, and plus Cl minus. So when treated with AgNO3, so what we would get, 1 molecule of AgCl and NO3 minus 1 ppt, AgCl का 1 mole ppt मिलेगा. And then our last one is CO, the last one is CO NH3 whole thrice Cl3, right? So what we would get in that condition, CO in solution, it remain as it is, no ion liberate. No ion liberate, it means no AgCl PPT will form, right? So these are the conditions. So on the basis of it, he postulated all those points. The first one, we also observe many important information here. You can see the precipitate, I mentioned it. Number of particles कितने मिल रहे हैं, 4. Total charge कितना हो रहा है, 3 minus and 3 plus, so 6. And the molar conductance, जितने ज़्यादा number of particles मिलेंगे molar conductance उतना ज़्यादा होगा, तो molar conductance 390 है. फिर देखिए number of particles कम होते जा रहे हैं, precipitate कम होते जा रहे हैं, और तो वही उन्होंने पहली चीज जो प्राइमरी वैलेंस इज सेटिस्फाइड बाय नेगेटिव आयंस, उनके हिसाब से मानना था कि Cl जो है वो आयनाइजेबल होगा. अब यहाँ पर नए जैसे जैसे नए कॉन्सेप्ट्स आते गए, तब वहाँ पर ये इश्यूज आते गए कि कैसे डिफरेंट अरेंजमेंट, डिफरेंट जो है हमें वैलेंस देखने को मिलता है। बाद में ऑक्सीडेशन नंबर का मीनिंग अलग हो गया, लेकिन उनके लिए उसके बाद भी अल्टीमेटली वो मानते थे कि 3 आयंस जो है वो आयनाइजेबल होने चाहिए प्राइमरी वैलेंस, ऑक्सीडेशन स्टेट के हिसाब से वो डिसाइड करते थे, जो कि बाद में सही नहीं रहा। सेकेंडरी वैलेंस की बात करें तो काफ़ी हद तक सही थे। ये बात अलग है कि नाउअडेज सम दैट positively charged ligands also possible, and the last one he was also correct for last one. There is a special arrangement जिसे polyhedra नाम दिया था, but the second one is not exactly correct because in all those cases Cl3 is not always ionizable, right? But coordination number of cobalt is 3+ always, right? So this is Werner's balance theory, and on the basis of it is helpful for prediction of molar conductance. It is helpful for predicting that abnormal molar mass, Van 't Hoff factor we can see. I की वैल्यू अगर 100% डिसोसिएशन है तो 4 हो जाएगा, राइट, क्योंकि 4 पार्टिकल्स बन जाएंगे. दीज ऑल आर वेरी, दिस थ्योरी initially was very successful, very helpful for determination of or for explanation of many principles, many theories. But nowadays it is also useful, but better theories are available to describe. In this theory there is no explanation about the bonding between central metal ion and ligand. There is explanation about arrangement, but no explanation about bonding. No explanation about primary valency. The primary valency is 100% is not explained by this. जो उन्होंने explain किया है, that is not accordingly, that is not according to modern concept. That is not according to modern concept, right? क्योंकि modern concept में हम ऐसा नहीं मानते कि वो केवल ionizable है, हो भी सकता है, नहीं भी हो सकता, हम ऐसा मानते, right? So this is Werner's valence theory. This is first theory. Second theory is similar to the second theory is valence bond theory, and it is almost similar to the valence bond theory we had discussed in class 11th, right? But a slight difference also there, because a lone pair electron is involved here. So the first point is metal atom or ion under the influence of ligands, their orbitals mixed or hybridized and form hybridized orbital for bonding or prepare hybridized orbitals. The first one is hybridization, mixing of available orbitals of atom or ion in influence of ligand. If two atoms or ion S or P were involved, the hybridization will be sp2 sp. If 2p and 1s is involved, sp2. If 3p and 1s is involved, sp3, sp3d2, sp3d, sp3d, sp3d2, and one more is possible, that is d2 dsp2. One more is possible, that is dsp2, for which the geometry will be square pyramidal, for which the geometry will be square planar, like sp3. The coordination number will be 4 for them also, for that hybridization also. But उसके लिए क्या हो जाएगा, dsp2, that will be dsp2, और coordination number 4 होगा, that dsp2 coordination number will be 4, dsp2 coordination number will be 4, और geometry is square planar. Geometry कैसी होगी, square planar होगी, geometry will be square planar. Is it okay? सो इस चीज़ को हम ध्यान रख सकते हैं. तो ज्योमेट्री विल भी एक और उसमें इंक्लूड हमें करना है, इस चीज़ को ध्यान रखिए लोग. सो ओवरऑल जो है वो हाइब्रिडाइजेशन, दिस इज कोऑर्डिनेशन नंबर, वी कैन से दिस इज कोऑर्डिनेशन नंबर 2 3 4. 4 में 2 हो जाएंगे, sp3. इट इज, इफ इट इज sp3 टेट्राहेड्रल, इफ इट इज dsp2 स्क्वायर प्लेनर, अदरवाइज trigonal bipyramidal, and last one is octahedral. Very common are square pyramidal, tetrahedral, and octahedral. That's why we had discussed about isomerism, discussed in isomerism about these structures only, right? Now the hybridized orbitals, I will explain each and every point. The first point is this: available orbitals, required number of orbitals mixed, right? And this is called hybridization. And after hybridization, according to VSEPR theory, जो है हमें geometry मिल जाएगी. And afterwards lone pair after filled orbital of ligand will overlap with hybridized orbital of metal atom or ion. तो filled orbital जो है that will overlap with hybridized orbital, right? Now next point is the strength of ligand is described by a series. Actually, strength for what? Ligands have having negatively charged or having lone pair of electrons, so obviously they produce some electric field. So the field on the basis of field produced by the ligand, all the ligands are arranged in a series known as a spectrochemical series. Those can produce a strong field are known as strong field ligands, and those can produce weak field are known as weak field ligands. So as we move toward carbon monoxide, fields are strong field, or as we move toward iodide end, fields become weak field ligand. There's no exact division कि कहाँ से कहाँ तक strong field होंगे, कहाँ से कहाँ तक weak field होंगे, but till H2O, from iodide to H2O, it is considered as ligands are considered as weak field, and after H2O, ligands are considered as strong field. But there's no exact demarcation. This is the problem of valence bond theory. There's no demarcation, right? So what will happen, that field produced by the ligand, is actually negative field, right? So negative field repel existing electron in metal ion or metal atom. In that case, unpaired electron start pairing if required. Pairing occurs only when if required. Required for what? Required for ligand's electron. I will discuss with example this all also, right? So ligands start pairing. Strong field ligands cause pairing with great effect. Weak field generally pairing नहीं कर पाते, हम कह सकते हैं. Now complex compound in which overlapping occur after pairing of electrons if required are known as low spin complex. जिनमें pairing हो जाती है उसके बाद जो complex बनते हैं, they are considered as low spin complex. It means अगर strong field ligand है, it may cause pairing, and in that condition, if pairing occur in that condition, that compound will be low spin complex. क्योंकि pairing होने के कारण से spin quantum number की वैल्यू कम हो जाएगी, so that will be low spin complex. Otherwise, that will be high spin complex. Complex in which pairing occur, generally such complex in which pairing occur use inner orbital for bonding. Pairing हो जाने के कारण से कुछ अंदर वाले ऑर्बिटल खाली हो जाते हैं और उन्हीं का बॉन्डिंग के लिए यूज किया जाता है. So such complexes are called inner orbital complex, and other use outer orbital, hence are known as outer orbital complex, right? Here I'm going to explain with example about or postulate of valence bond theory, right? So इस चीज को अपन ध्यान रखेंगे कि हम बैलेंस बॉन्ड थ्योरी के बारे में बात करेंगे और उसी के बेस पर यह डिस्कशन होगा, राइट? VBT1 के नाम से सेव करते हैं इसे, और अगर ज़रूरत पड़ी तो मैं इसका स्लाइड में ऐड करूँगा, राइट? नाउ ओके, अब हम आ जाते हैं नए पे. तो लेट वी डिस्कस VBT विद एन एग्जाम्पल. वी हैव अ कंपाउंड like Cr, right? CrCl6, right? CrCl6, और यहाँ पे हो जाएगा क्या? K3CrCl6 और यहाँ पे हो जाए ये K3CrCl6 हमारे पास कंपाउंड है। ध्यान दीजिएगा। अब फर्स्ट वन हम देखेंगे, क्रोमियम इज इन 3+ ऑक्सीडेशन स्टेट, सो हम 3+ लिखते हैं, एंड द ऑक्सीडेज दैट आर्गन, एंड देन S जो है वो खाली पड़ हो जाएगा। दैट normal configuration of chromium that we know is 4s1 3d5 और 3 इलेक्ट्रॉन निकल गए, तो इट रिमेन एज 3d3। क्या बचा हमारे पास? ये 3d3। सो वी हैव 3d3 कॉन्फ़िगरेशन। One, 2, 3. Now 4s is remain vacant, and then 4p is again remain vacant. So we need 6 chlorine to bond, and we have 6 orbitals vacant. So these 6 orbitals mixed together, and this will be sp3d2 hybridization. Because we have orbitals, and the chlorine is weak field ligand, but here in this case there's no effect of ligand's strength, right? Because we have required orbitals. So sp3d2, 6 orbitals we get, and these 6 orbitals are hybridized, sp3d2 hybridized orbital, and vacant orbitals all. Now chlorine ion will put electron here, their lone pair electron here, it means it overlap with vacant sp3d2 hybridized orbital. Filled p orbital of chlorine, because chlorine में filled p orbital is obviously p orbital ही होगा, तो filled p orbital of chlorine is overlapped with sp3d2 hybridized orbitals, and the geometry will be octahedral. So this is chromium, this is Cl, this is Cl, this is Cl, this is Cl, and this is Cl, and one more Cl is here. So ये पूरा इस तरीके से जुड़ जाएंगे, ऐसे जुड़ जाएंगे, ऐसे जुड़ जाएंगे, ऐसे जुड़ जाएंगे, ऐसे जुड़ जाएंगे, and that all will be bonded with here, with here, with here. This will bonded with here, and here, and here, and this will form octahedron, right? So that's why it is octahedral geometry, right? So this is simple case of bonding, but now here involving strong field ligand are the cases in which effect of ligand strength will operate, right? So ऐसे cases पर अपन बात करेंगे जहां पर ligand जो है वो ऑपरेट हो रहा होगा, ठीक है, ligand field strength जो है वो ऑपरेट हो रहा होगा, हम इसके बारे में बात करते हैं, एक ऐसे एग्जाम्पल से बात करते हैं, right? So here is one example, that is FeCl whole 6 and 4 minus, right? FeCl whole 6 4 minus. In this case Fe will be Fe2 plus, you can understand it. So 2 electron will remove from that S subshell, so remaining is 3d6 configuration. It has 3d6 configuration, right? So D is filled, 1 2 3 4 5 and 6. Because chlorine is weak field ligand, no pairing occur, and the remaining like 4s 4p and 4d, 2 4d orbitals actually required. So 4s 4p and 2 4d orbitals will hybridize, that hybridization will be sp3d2. 6 orbitals will form, 1 2 3 4 5, and in these orbital chlorine will put their lone pair electrons. It means chlorine, p orbital of chlorine will overlap with sp3d2 hybridized orbital of Fe2+, and then by this way क्या बन जाएगा, ऑक्टाहेड्रल कॉम्प्लेक्स बन जाएगा. क्या बन जाएगा, ऑक्टाहेड्रल कॉम्प्लेक्स बन जाएगा. मैं ऐसे बना देता हूँ, अब जैसे अपन बनाते आ रहे हैं, क्लोरीन 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 एंड वन मोर क्लोरीन इज हेयर. दिस इज स्पेशल अरेंजमेंट अकॉर्डिंग टू वर्नर, राइट. और सेंटर में यहाँ पर एफ ही रहेगा और ऊपर ये हो जाएगा, ये आपका हो गया कोऑर्डिनेशन पॉलीहेड्रा. Right. What would happen in case of VVT? What would happen in case of let that strong field ligand will be a part of complex. अगर strong field ligand complex का part होगा तब क्या होगा. For example, here we are going with one more example. FeCN whole 6 and then FeCN whole 6 then 4 minor. Now again the same thing, Fe2+, the configuration is argon 3d6, but here this is the configuration of 3d6, 1 2 3 4 5 and 6. This is the configuration of 3d6, but here the important thing is this. What is important in this? The important thing is this, because CN is cyanide ion is strong field ligand, and what will happen? Cyanide ion is strong field ligand, and hence due to its strong field, what will happen? These electrons pair, ये इलेक्ट्रॉन इसके साथ पेयरिंग कर लेगा, ये इलेक्ट्रॉन इसके साथ पेयरिंग कर लेगा, और दो d ऑर्बिटल, क्योंकि sp3d2 हाइब्रिडाइजेशन बनाना है तो दो d ऑर्बिटल खाली कर देगा. तो ये this is called migration of electron or pairing of electrons. So 1 2 3 4 5 and 6. The cause of exact pairing is not explained, was not explained by VVT, right? It will explain by a crystal field theory, but यहाँ ऐसा मान लिया गया कि ये फील्ड के कारण से होता है, but it is not exact reason, right? और दो ऑर्बिटल्स खाली हो गए, बाकी के s हमारे पास बचा ही हुआ है, और उसके बाद वाला जो है हमारे पास p भी बचा हुआ है. So in that case is s p, so दो d के ऑर्बिटल्स, one s ऑर्बिटल and two p ऑर्बिटल will combine and form sp3d2 hybridization. So this will be sp3d2 hybridization, and again 6 orbitals will form, and these 6 orbital combine, the cyanide ion will put their electrons in these 6 orbital, 1 2 3 4 5 or 6. ठीक है, तो cyanide ion will put their electron, cyanide will act as a ligand and put their electron here in d orbitals, and that's why the hybridization will be sp3d2, and the bonding will be, the geometry will be, सारे अपने अपने इलेक्ट्रॉन्स देंगे, so coordinate bond will form and the geometry will be octahedral. Cyanide, 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 cyanide and cyanide and the iron in the center. So geometry will be octahedral. Now in this case you can see the spin reduce. So this complex is termed as, क्योंकि स्पिन कम हो रहा है, इसे कहेंगे हम लो स्पिन कॉम्प्लेक्स. क्या कहेंगे? लो स्पिन कॉम्प्लेक्स. एंड इनर ऑर्बिटल का इन्होंने यूज किया. आप देख सकते हैं पेयरिंग हो गई, इनर ऑर्बिटल का यूज हुआ, तो इसीलिए इन्हें क्या कहेंगे? आउटर ऑर्बिटल कॉम्प्लेक्स भी कहा जाएगा. So if it's spin reduced, that will be low spin complex. If inner orbital is used, that will be inner orbital complex. Inner orbital complex क्या कहा जाएगा इन्हें? Inner orbital complex. इस कॉम्प्लेक्स को क्या कहा जाएगा? Inner orbital complex कहा जाएगा. राइट. और अगर हम इससे पहले वाले केस में देखें, तो क्या हो जाएगा? अगर हम इसके पहले वाले केस में देखें, वेट अ मिनट, अगर हम इसके पहले वाले केस में देखें, इसके पहले वाले केस में देखिए आउटर ऑर्बिटल हो रहा है, स्पिन कम हो सकता है बट नहीं हो रहा है, तो इसे हम कह सकते हैं, स्पिन कम हो सकना होना चाहिए, फिर भी नहीं होता है, तो इसे कहेंगे हाई स्पिन कॉम्प्लेक्स. इट इज हाई स्पिन कॉम्प्लेक्स. इसे हाई स्पिन कॉम्प्लेक्स कहा जाएगा. एंड द सेकेंड वन इज, it is using this compound for bonding, outer orbitals are used. That's why it may use inner orbital, but because ligand is weak field ligand, so use outer orbital, so they are called outer orbital complex. इज इट ओके सर एवरीवन? तो ये चीज आपको शायद समझ में आ गई होगी कि कैसे हम इनर ऑर्बिटल कॉम्प्लेक्स बताएंगे, कैसे आउटर ऑर्बिटल कॉम्प्लेक्स बताएंगे. वैसे ये चीज याद करने की जरूरत नहीं है. जैसे D1 की अगर मैं बात करूं, यहाँ ध्यान दीजिएगा, अगर मैं यहाँ पर बात करूं D1, तो हम जानते हैं कि D1 में हमें पेयरिंग की कोई जरूरत नहीं पड़ेगी. तो D1 में कोई फील्ड स्ट्रेंथ का कोई लेना देना नहीं, इनर आउटर की कोई बात नहीं होगी. D2 में हमें जरूरत नहीं पड़ेगी, तो वहाँ भी कोई बात नहीं होगी. D3 में हमें कॉन्फ़िगरेशन में कोई जरूरत नहीं पड़ेगी, तो वहां पर भी. तो अगर हम ऑक्टाहेड्रल कॉम्प्लेक्सेस की बात कर रहे हैं, फॉर ऑक्टाहेड्रल कॉम्प्लेक्सेस, क्योंकि हम ऑक्टाहेड्रल कॉम्प्लेक्सेस के बारे में ही हमने डिस्कशन किया है. सो फॉर ऑक्टाहेड्रल कॉम्प्लेक्स इन केस ऑफ D1, D2, D3, देयर इज नो हाई स्पिन और लो स्पिन कॉम्प्लेक्स, नो आउटर ऑर्बिटल और इनर ऑर्बिटल कॉम्प्लेक्स. राइट. सिमिलरली इन केस ऑफ लाइक D7, सो D7 कॉन्फ़िगरेशन में क्या होगा? अगर हम पेयर भी कर दें इलेक्ट्रॉन्स को, अगर हम इलेक्ट्रॉन्स को पेयर भी कर दें 1 2 3 4 5 और 6, राइट, और 7, सो अब पेयर भी कर दें तो भी हमारे पास एक इलेक्ट्रॉन बचा रहेगा. द D7 कॉन्फ़िगरेशन इज फॉर कोबाल्ट. इसलिए कोबाल्ट को लेकर कुछ इश्यूज होते हैं. ये एक इलेक्ट्रॉन माइग्रेट करके अगले d ऑर्बिटल्स में चला जाता है अगर स्ट्रॉन्ग फील्ड लिगेंड है तो. राइट. सो D7 में हो जाएगा. D8, D9 और D10 कॉन्फ़िगरेशन में आप देख सकते हैं कि अगर पेयरिंग हो भी गई तब भी ऑक्टाहेड्रल कॉम्प्लेक्सेस के लिए कोई फर्क नहीं पड़ेगा, क्योंकि इनर ऑर्बिटल्स, 2 d ऑर्बिटल्स नहीं मिल पाएंगे. एक बात हमेशा याद रखिएगा, जो भी d ऑर्बिटल्स यूज हो, देयर मस्ट बी सेम प्रिंसिपल क्वांटम नंबर, शेल सेम होना चाहिए, वही d ऑर्बिटल. ऐसा नहीं कि 4s का एक यूज कर लिया और आगे मतलब 4d का एक यूज कर लिया या 3d का एक यूज कर लिया और आगे 4d का यूज करें. नो, यू नीड टू यूज बोथ फॉर योर रिक्वायरमेंट. इसी तरह से अगर हम एक और कॉम्प्लेक्स की बात करते हैं, लेट वी डिस्कस अबाउट वन मोर कॉम्प्लेक्स फॉर टेट्राहेड्रल और स्क्वायर प्लेनर के लिए बात करते हैं. जैसे अगर हम NiCl4 के लिए बात करते हैं, फॉर NiCl4 द कॉन्फ़िगरेशन विल बी N2+. So Ni, the configuration is Ni2+, and the configuration for Ni2+ will be argon, and S से 2 इलेक्ट्रॉन निकल जाएंगे, that will be 3d8. 3d8 configuration. 3d8 configuration in that case, and we need to know, we need to want 4 ligand. So we need 4 vacant orbitals, right? We need 4 vacant orbitals. 1 2 3 4 5 6 7 8, right? So and remaining, so 4s is remaining and p is remaining. So because chlorine is weak field ligand, so this sp3 will hybridize and form 4 valence orbitals. 4 valence orbital they form, sorry, and chlorine will put their lone pair electrons in these orbital. It means chlorine will overlap with this hybridization will known as 1s and 3p sp3 hybridization, and orbital of chlorine will overlap with sp3 hybridized orbital. And obviously if it is a strong field, so one electron may be, because we need 4, so we can take 1d, so one electron can paired if it is strong field ligand. So in that case it is low spin complex and outer orbital, it is high spin complex. एक ऐसा complex होगा high spin, because no pairing occur in it, और outer orbital complex कहलाएगा, because there is possibility orbital complex. But let it is for complex NiCN or NiCO whole 4. If it is NiCO whole 4, I'm not talking here about NiD8 so 4s. Okay, here I'm not going to discuss about NiCO we'll discuss later. NiCN whole 4. In case of NiCN whole 4, what will happen? The same configuration is there, configuration तो यही रहेगा, but क्या होगा? कॉन्फ़िगरेशन तो सेम ही रहने वाला है. 1 2 3 4 5 6 7 8 and the S are vacant, P are vacant, और आगे के D भी vacant है. But due to strong field intensity of cyanide, one electron will paired with this. So what will happen? This is 1 2 3 4 5 6 7 and 8, and one orbital is vacant. So one s orbital is also used. This is 4s, this is 4p, this is 4s, right, this is 4p, and now 1d is available. So here is dsp2 hybridization is there, dsp2 hybridization is there, and due to dsp2 hybridization the geometry will be square planar. Cn, Cn, Cn and Cn. Square planar geometry will be. यहाँ पर क्या geometry हो जाएगी? Because sp3 hybridization will be, so it is tetrahedral geometry. Tetrahedral geometry. C Ni. So one Cl is here, one Cl is here, one Cl is here, and another Cl is here. So this is tetrahedral geometry. And but in this complex, inner orbitals has been used and pairing occur. That's why it is lower spin complex, low spin complex. Above one is high spin complex. This is low spin complex because spin quantum number decrease हो रहा है. And the next one is inner orbital complex. Inner orbital complex. So मुझे जो चीज़ कहनी थी, जो मैंने d ऑर्बिटल में भी आपसे शेयर किया था, कि that sometimes ligands intensity affect dipole moment. तो you can see कि अगर strong field ligand है तो obviously pairing possibility है, और अगर pairing होता है तो obviously number of unpaired electron change हो जाएंगे, और उस condition में dipole moment और paramagnetic nature भी change हो सकता है. So remember it, right? One electron अगर ऐसी कंडीशन में होता है तो कैन शिफ्ट इन अदर d ऑर्बिटल्स, राइट. 2 इलेक्ट्रॉन्स कभी भी शिफ्ट नहीं होंगे. जैसे कोई भी कंडीशन हो जाए कि 2 इलेक्ट्रॉन्स किसी अदर d ऑर्बिटल्स में शिफ्ट हो जाए, ऐसा नहीं होगा. जैसे मैंने कोबाल्ट के केस में आपको बताया था कि एक इलेक्ट्रॉन शिफ्ट हो सकता है, बाकी दोनों के अगर एक इलेक्ट्रॉन कहीं बचता है सिंगल, और आपको पता है कि अंदर वाले ऑर्बिटल्स यूज करने हैं. रिमेंबर इट, जनरली इनर ऑर्बिटल कॉम्प्लेक्स are more stable as compared to outer orbital complex. We'll discuss about it later. See, watch this video, and जो भी issues हैं we will discuss in our class.